circle theorems, and this one is on secant and tangent theorem. So you start with the first theorem here, that's chord theorem. You are going to prove why AS times SB is the same as CS dot SD. So this is our diagram, our nice diagram. So that's our line to cross it. Then we can it has formed an angle here. What angle are we forming here? And this is our S. The center is our S. And so we have to prove in the diagram AS. So in the diagram, I say triangle ASD and triangle CSD. So that's proof. That's what we are going to prove it, right? Good. And we know that A1, where's our A1? This is our A1 equals A2. And do you remember this theorem under the circle theorem? We said that angle in the same segment are equal. Good. So therefore, the angle here 2 and here 2 be equal. So let's make this angle B1 and B2, right? So the angle in the same segment are equal. That's our theorem, right? So the third angles are equal. If this one equal, we are saying that therefore these angles are equal. That's the third angles are equal. Since the third angles are equal, hence triangle ASD, this triangle, and triangle CSB are similar. And we have talked about similarity. Do you remember? Yes. And we are saying that the similarities, we will take the ratio. Since they are similar, the ratio. So therefore, AS, this line here, is the same as SC. So we are saying that the ratio of AS, since they are similar, the ratio of AS is to this. So therefore, AS divided by CS. Then, since they are similar, SD also divided by SB. And also, AD is also the same as CB. Similarities, yes. So we are going to use these two, right? AS divided by CS equals SD out of SB. Therefore, if you do cross multiplication, AS times SB equals CS times SD. That's why we are saying that we are proving that AS times SB the same as CS times SD. So these are proved. Therefore, QUD. Good. That is chord theorem. Subscribe to Senior Pelus for more videos. So circle theorem, and this one is part 2. This one is on secants and tangents. So we talk about chord as our first theorem. We are on secant, and we know what secant means, right? So you see that this line, it touches two parts of the circumference or the circle. So that's the secant. That's why I say secant. So these two lines are 2 seconds, right? So this secant, because it touches this point and this point, so it's a secant. Then let's join a line from here to here. Then we join a line from here to here. Okay. So we name here A, S, and D. That's our first triangle, ASD. then CSB. That too is also another triangle. So prove in the triangle ASD, that's our first triangle, and CSB, what is there? We are saying that we have B1 and B2. And remember this one, angle in the same segment. When you are doing the circle theorem, we did mention that angle in the same segment are equal. So therefore, our B1 is same as B2. And this S is common because both of the two triangles are sharing this angle here. That's why you see that S is common. Therefore, the third angles are equal. Therefore, the third angle are equal. Since B1 equal B2, S common, third angles are equal, we are saying that ASD and CSB are similar. And we know what similarity means, right? So AS is the same as CS. So they are similar. So AS divided by CS, that's what similarity means. Similarity means talk about ratio, right? Good. Then SD, so the same as SB, right? Then DA, so the same as BC, right? So we are going to use this. So we use these two, then we do cross multiplication, then we conclude. So if we do cross multiplication, AS is multiplied by SB, and then CS also multiplied by SD. So we have proved it using the cross multiplication. Then QED, it has been proved. Okay, that's our second theorem. And our next theorem on tangent and secant. This one is tangent secant theorem. We have to prove that AS dot SB is ST square. So this is our diagram, and that's our tangent, a line that touches the circumference. And this one line cut the 2 points of the circle, that's the secant. So this is our secant, this is our tangent. Okay, that's why I say tangent secant theorem. So let's join this line here, another line here, so that we can prove it with easy. So therefore, this is our diagram. So we have SAT, that's a nice triangle, right? So SAT is the same as SCB. That's what we want to prove. So SAT and STB. So this small triangle SAT and then STB. Let's see whether they are similar. So B1 and here too is B2. Why are we saying that B1 is the same as B2? Angle in alternate segment. Do you remember under circle theorem? We said that this angle here the same as the angle here. And we said that angle is an angle in alternate segments. Then this S, they are sharing the same angle here. Therefore, S is common. Then the third angles are equal. Then the third angle are equal. So therefore, this similarities proof. So angle ASD and triangle CSB are similar. So if they are similar, then SA is the same as ST, right? ST or TS the same as BS, right? Then AT, so the same as TB. So we are going to use these two. So we do cross multiplication. So if multiply SA by BS, then ST times TS, they are the same. So that one we get squared there. That's why we are saying that SA times SB equals ST squared. So these two has been proved. KUD. Subscribe to Senior Pelus, my YouTube channel, for more videos. Thank you. So let's solve some example on these theorems. Tangent secant theorem. It's also known as the power theorem, right? That's the last thing that we prove. So prove that SA dot SB equals ST squared. This is our diagram. So this is our example. And this is our diagram. So find the value of S and Y. With this diagram, I find the value of S and Y. Know that TS squared the same as SA times S what B. So solution. And we are saying that SA times SB is ST squared. Now our SA here is what? 3, right? From here, SB will be what? Because here we have 4S3. So 3 plus 4 is 7 plus the S. So our SB is 7 plus S. So it means that 3 times 7 plus S equals 6 squared. So this one we get 36 here. So I will divide both sides by 3. Then it will be 7 plus S equals 12. Then let's make S the subject. So we subtract 7 from both sides. Then our S is 5. Now we know our S. How will we find our Y? Right? We have the other theorem. Do you remember that theorem? So our Y is this Y times the 3 here, the same as the 4 times the S here. Do you remember that theorem? Don't remember, right? Okay, so this Y times the 3 here, and then the 4 times this 3 here, they are all similar, so they are the same, right? Good. So we know our S. Y times this 3, then 4 times our S here, then our S is 5. Therefore, we can find our Y. So we have 3Y equals 20. If that goes up by 3, our Y is 6.67. So that's for the circle theorem and the power theorem. That's what secant tangent theorem. Subscribe to Senior Pelus, my YouTube channel, for more videos. Thank you.